In this video, we're going to examine the GCF and the LCM of monomials. Let me remind you of what a monomial is. It is a product of numbers and or variables. So the four examples you see on your screen, they're all held together by multiplication. So they are monomials. Let's review what a greatest common factor is. It's the largest shared factor of the monomials. So, for example, 16. If I list all the factors of 16, well, that's all the values that go into 16 evenly with no remainder. So that would be 1 times 16, 2 times 8 gives me 16, 3 doesn't go into it, but 4 does. It would be 4 times 4. So there's my entire list of factors of 16. Now 24 would be 1 and 24, 2 and 12, 3 times 8, and 4 times 6. So what I'm looking for now is the largest shared factor. So they both have 1, both have 2, both have 4, both have 8. So the GCF here would be 8. Greatest common factor, because it's the greatest factor that they have in common. Now, let's change our thinking now for least common multiple. Remember what this is. This is your smallest shared multiple. So you got to think about what multiples are. Multiples are achieved by multiplying something like 16 times 1. Well, 16 times 1 is 16. 16 times 2 is 32. 16 times 3 is 48. 16 times 4 is 64. And I may have to keep going till I find a common one, but I'm going to switch to 24. 24 times 1 is 24. 24 times 2 is 48. I've got it. I can stop here. It's the first time they have a value in common. 48 is the LCM. Now, there are many methods for finding the LCM and the GCF. You can go down to the product of primes. So if you are not good with mental math, you may want to look up a video on using prime factorization to find the GCF. But I'm going to encourage you to use your multiplication facts because it's quicker. Okay, so now let's find the LCM and the GCF of the two monomials that we see on the screen, 4x squared and 6x to the fourth. So what I'm thinking, I always start with the greatest common factor. And I like this visual because this is how my brain thinks of it. The GCF is always smaller than or equal to your given monomial, so it's underneath is how I write it. In other words, I could divide the 4x squared and 6x to the fourth by the greatest common factor. All right, now let's figure this out. So what I do is I look at 4 and 6. If you have to list the factors of 4, they would be 1, 2, and 4. Factors of 6 would be 1, 2, 3, and 6. What's the greatest one they have in common? It would be 2. Now, I think many of you can look at 4 and 6 and just think, what's the biggest thing that goes into 4 and 6? It's 2. Now, the largest power of x that goes into both x squared and x to the fourth is the variable with the smaller exponent. So the x is in both places. It would be x squared. Now, why is this? This is because I've started with an x squared and x to the fourth. I can divide each of these by x squared and not get any remainder. X squared divided by x squared is 1. X to the fourth divided by x squared is x squared. So my GCF is 2x squared. Now, least common multiple. Change your thinking. So you're thinking, what is the smallest number that 4 and 6 both go into? So it's going to be larger than 4 and 6. What my strategy here is I look at 6 and I start thinking of its multiples. So 6, 4 doesn't go into 6, I double 6, that's 12. Does 4 go into 12? Yes, it does. So my least common multiple is 12. And now I take the variables. I have to take each of the variables and I take the one with the larger exponent, 12x to the fourth. So again, this one is going to be bigger. It's always bigger than or equal to your given information. All right, let's do another practice one. GCF of 3 and 9 is how I start. Well, the largest value that goes into 3 and 9 would be 3. Now look at your variables, x to the fourth and x. What do they have in common? They have an x to the first. You take the one with the smaller exponent, which would just be x. Y's, take the one with the smaller exponent, it would just be y to the first. 3xy is the greatest common factor, the largest factor that they both have in common. Now, LCM. Again, I'm thinking of multiples, so it's equal to or bigger. What is the common multiple here? So I start with my larger one, 9, and I think, does 3 go into 9? Yes, it does. So the LCM is 9. Take my variables, x. The one with the greater exponent is x to the 4th. One with the greater exponent here is y squared. So 9x to the 4th, y squared is your LCM. All right, another practice one. Just quickly changed my variables here. I put the same ones twice. All right, so our GCF is looking at 10 and 2. What's the largest thing that goes into both? That's going to be 2. Now look at your variables. What's in common? I have an a to the first power in both places. There's an a to the second, but I just need to the first. Now, the b's, there's not a b in both places, so the GCF is just 2a. Now, least common multiple. So I just start with the bigger one, which is 10. Does 2 go into 10? Yes, it does. So 10 is the least common multiple. Now I look at my variables. I have an a, take the one with the greater exponent, is a squared, and then I have a b. I don't have it in both places, so I just take a b to the first. Final practice one, 3 terms here. So now the biggest thing that goes into 3, 12, and 5, well, that's going to be 1. That's going to be your common factor. Now, the x's, what is the smallest exponent? Would be x to the first. So it's 1x to the first, or just x is your GCF here, the least common multiple. Now, we need to think the smallest one, that number that both 3, 12, and 5 go into. So I start with my biggest. I start with 12, and I start doing multiples of that. That would be 24. 3 goes into 24, but not 5. Double that would be 30, or not double it, but multiply by 3 would be 36. 5 doesn't go into that. Then 48, then 60, there it is. 3 goes into 60, so does 5, so does 12. So my least common multiple is 60. X to the, take the one with the biggest exponent, so 60x squared. Okay, so this was kind of a mental math way of figuring out your greatest common factor and least common multiple. If this is not clear, I would suggest looking up the prime factorization method.